Okay, so today we're going to be focusing on cells of the nervous system and something called the reflex arc. Um, so we'll start. I know our note the other day talked about neurons, but they did leave out these types of cells that are really, really important and are part of the nervous system called glial cells. So I just want you to pretty much take notes today. Stop and freeze this lesson and take down what you need to. I just want to go over a few concepts, and the reflex arc is just something you're going to need to know. So, glial cells actually outnumber your neurons 10 to 1. It states here that they're non conducting cells, and that's what your textbook states. However, that information is a little outdated. They have discovered that glial cells, some of them actually do, in fact, conduct electricity. Their purpose is to nourish the neurons, and really important is to remove their wastes while you're sleeping. Your neurons in your brain take a lot of energy. There's a lot of cellular respiration going on in there. They're conducting electricity, and they make a lot of waste product. And that waste product, because these cells do not undergo mitosis and do not make more of themselves and replenish themselves, removing those wastes so they don't get damaged is really, really essential. Which is why if you don't sleep, your brain will literally shut you down and force you to sleep, because removing the waste is really absolutely essential. And they also defend against infection. So these are really important cells, and we don't want to forget about them, right? So they're there, and they have a very important job. Your neurons couldn't work without them. So an example is Schwann cells. And then, of course, there are neurons. Oh, excuse me. These ones conduct electricity and release chemicals. So we're going to be really looking at these in great detail. So the basic structure of a nerve cell, of course, you have your cell body, and that is the part of the cell that is just like the cells we've studied since grade 8, right? They have the nucleus, the cytoplasm, they have all those organelles. It's where the metabolic reactions happen. The mitochondria are there. And it also processes inputs from the dendrites. All that means is it conducts electricity from the dendrites to the axon. So if you remember from the other day, we talked about dendrites. These are really important. That's where the electricity starts. That's where the nerve impulses start. So that's the starting point for conducting electricity through the cell. And remember, neurons have direction. And then there's the axon, and that conducts impulses away from the cell body. They range in length from 1 millimeter to 1 meter, which I'm going to come back to here. So neurons can be different shapes and sizes. A neuron, one cell, travels all the way down the back of your leg. It's called the sciatic nerve. So that's the one that has the axon that is 1 meter long. That's a huge axon. Runs all the way down the back of your leg. And because it's so long, it causes people a great deal of issue as they get older. You can pinch that sciatic nerve. It's just so long. There's all kinds of places where you can run into problems with your sciatic nerve. And man, if you have problems with your sciatic nerve, it is really painful. There's nothing like nerve pain. You really can't get away from it. And I had a sciatic nerve problem from carrying one of my children on the same hip all the time. And I ended up with a pinched sciatic nerve, and man, it was brutal. So yeah, those great big long nerves, not the best. There's just a lot of places you can run into problems with them. Now the end of the nerves are called axon terminals, and that's where you're either going to conduct the electricity to another neuron at a synapse here, or it's going to end at a gland or a muscle. So it's either going to cause a muscle to contract, or a gland, it's going to release chemicals, or it's actually going to cause the signal to go into a different neuron, because remember, this is all about pathways, and that's multiple neurons sending signals or electricity from one to the other. Okay, so when we classify neurons, there's 3 types. Of course, there's way more than 3 types, but they all kind of fall into one of these 3 categories. There's the sensory neurons, so hopefully you watched that little video on the senses. These neurons have sensory receptors at the end. So certain stimuli will cause them to conduct electricity. So your eyes have photoreceptors, and your nose has chemoreceptors, and your skin has thermoreceptors. So stimuli will cause electricity to start in these types of neurons, and it will start moving down a specific pathway. They actually feed into the central nervous system, which are your interneurons. So your interneurons, are in fact your brain and spinal cord. So the information or electrical signal is fed into the brain and spinal cord. It's processed, and then another signal is sent out if something needs to happen. So it will be sent out to a motor neuron, and that transmits informations from the central nervous system to what we call effectors. Muscles, contract a muscle, like you're doing right now. Hopefully you're writing. And glands, perhaps to release a chemical, hormone. So there's the 3 types. So we have sensory receptors both internally and externally. Now, our external receptors are the ones we typically think of when we think of our senses, right? So you have your eyes, which have photoreceptors. So light will cause electricity to start to be conducted in these types of neurons, and they will conduct it to your brain. Ears are auditory receptors. The nose and the tongue are both chemoreceptors, although the nose will be called olfactory. It works like a chemoreceptor, just like your tongue. So the way chemoreceptors work is the chemical that you're smelling or tasting will be attached to that receptor. So I always think of the last time you smelled something really awful. Okay, what actually happened is little microscopic bits of whatever that awful smelling thing was actually attached themselves to a receptor in your nose, and the receptor conducted electricity, that neuron, to your brain where you perceived that smell as terrible. And same thing with taste. A little bit of the chemical attaches to a receptor on your tongue, and the electricity is then conducted to your brain so you can perceive the taste of it. So every time I smell a bad smell, I think there is a little piece of that stuck in my nose, and it's not a pleasant thought in the moment, but that's the way I think now. And then skin, you have all kinds of receptors. You have pain, you have pressure, you have thermo. So different stimuli will cause different receptors to conduct electricity. These are your external ones. Your internal ones are the ones inside your body, and they allow the brain to perceive things like hunger, thirst, muscle position, carbon dioxide levels in the blood. Excuse me, I don't know why I'm so tired. So, hunger, again, your stomach's empty, or your cells are needing sugar, energy, raw materials. They're going to send a signal to your brain to tell you you're hungry, and then you will hopefully react appropriately and go eat something. So I'm going to skip. Well, you can look over this little diagram I actually use, and then I hand it out, and we look at it and we do a little activity, which obviously we're not going to do. I will quickly explain what's going on. What I'm showing you here is a sensory neuron. So that's your sensory neuron. It will pick up, let's say it's in your eye, the light will be picked up and electricity will be conducted up in this direction to the interneuron, your brain, spinal cord, and back out the motor neuron, and it will cause a muscle to contract. So usually I use this diagram when I'm explaining students writing, and we do a little activity where we press down, but it's not going to make sense right now. So, this is in fact what is going on. You are looking at the screen. Your brain is perceiving what the electricity sends to it, the signal, and you are writing, and that's the muscle contracting according to the signal your brain sends out to the muscles in your fingers. So the reflex arc is really important. So a reflex arc is just usually 3 neurons. So those 3 neurons working together, one sensory, one interneuron, and one motor neuron. Okay. Now, the interneuron is a little bit different here. You're actually not engaging your brain, which I'm going to talk about. So these are involuntary responses, which means you're not thinking about them. They happen before you think to certain stimuli. So these are for survival purposes. The reflex arc is for survival. So a great example is blinking when an object moves towards your eye. And I've probably had experience with this more than a lot of people because I've raised 4 boys and they had Nerf guns, and who knows what they're throwing around. There's a lot of stuff flying through the air, especially when they were younger. And I was always astounded at the fact that my eye blinked before I could acknowledge that something was, flying towards my eye. I was like, wow, I can't believe I avoided that. But when you think about, when I show you what a reflex arc actually is, you'll see why I avoided it and then thought about it with astonishment afterwards. So your reflex arcs are 3 simple connections, usually only 3 neurons, that explain reflexive behaviors. So, of course, this doesn't apply to my example of things flying to my eye, because I would need an eyeball here. Maybe I'll just draw one in. I'll draw a little eye. Okay, there we go. I'm going to change this up. So the photoreceptors in my eye, the way this would work is the photoreceptors in my eye would see that little Nerf bullet flying towards it. And the signal, the electrical signal, would go through this sensory neuron. We call that the afferent nerve because it's going towards the spinal cord as opposed to efferent, which is exiting. Remember, efferent is exiting whatever we are, talking about, whether we're talking about kidneys or we're talking about the nervous system here. We're going in towards the central nervous system and then back out again. So the signal we would conduct electricity right to the spinal cord, where the signal would be conducted to the dendrites of the efferent nerve or the motor neuron, and it would just go quickly back out and to the muscle, cause the muscle to contract, and my eye would blink. Boom, done. So there's actually 3 neurons here, the afferent, the efferent, and the interneuron, which is located in the spinal cord. So this is a real quick action. And the reason I can be astonished about it after is when the signal comes up to the spinal cord here, as it's going back out, the efferent nerve, it's also going to travel up the spinal cord to your brain. But it takes longer to get to your brain. So my eye has already blinked before my brain can go, wow, that Nerf bullet was coming towards my eye and I blinked. So I've blinked before I even knew it was happening. And that's the way a reflex works. Okay, so it does go to the brain. You may be wondering why. Why does it go to the brain? Why is it even bothering you? The problem solved. It's going to the brain so you learn. You still need to learn. I should have learned that maybe I should have not bought so many Nerf guns in my house and maybe had a rule for them playing, Nerf guns in a room I wasn't in. Maybe that I could have learned that. I didn't. I just blinked on time. The learning is good for like touching hot things, right? Same idea. You've got the thermoreceptor in the finger, which is a type of neuron. It's on the end of the afferent neuron. So you've got your sensory receptor and the sensory neuron, or the afferent neuron, feeding into the spinal cord. It's going to send electricity all the way into the spinal cord. Okay, once it's in the spinal cord, it's going to directly exit back out. Efferent nerve, the motor nerve, that goes right to the bicep and causes the hand to move away. And then, of course, up to the brain as well. And then we learn, don't touch hot things. But we actually say ouch after our hand is already removed from the problem. So that's it for today. Just a little note, and we'll continue on